Okay, this is the SEG. This is how it works. I thought about it for a long time and I understand the concept. And he figured out, Cyril figured out everything you need to know, but like the weight and the dimensions. But what I figured out is I thought about how his idea works. And I'm pretty sure I'm right. And he intended for people to figure out how it works. So this is a roller. This is the stator. Stator neodymium, raw neodymium, Teflon, because you need an insulator, because it's also a capacitor that will carry a static charge. This is iron, which can also carry a static charge. And this is copper, which will also carry a static charge. This is the magnetic field. This is a horseshoe magnet with a wire wrapped around it. This is a wire, and this is the grounding cord here, because it's going to be a static charge that will jump from the roller to the coil of wire around the horseshoe magnet and travel back to the ground. And that's what static electricity does. And when it does that, it will power the horseshoe magnet for a split second. When this roller is in motion, it will push electrons from the copper this way, leaving the outside of the copper positive, and the electrons really want to travel back to the negative positive of the copper because they want to be stable, but they can't unless you connect the wire. We don't need wire because there's an axial magnetic field like a wire, and the magnetic field will become like a conductor. When it does, these electrons will, the motion of the electrons traveling across the magnetic field will create their own magnetic field, which will strengthen the permanent magnetic field. So what happens is when this roller is in motion around the copper, it will push the electrons this way, and they will travel back across the magnetic field through the roller to the positive side of the copper. And when they do, they will draw excess electrons from the neodymium, the raw neodymium. So here you can see electrons. These are the electrons being pushed, and when they pick up electrons from the neodymium, they will double. And you can see that, and they will travel back, and the copper, the positive side of the copper, will only take back the electrons that it lost, which means those two excess electrons will be stored as static electricity, which will jump to the roller. And then when this roller moves within range of the horseshoe magnet, the electrons will jump over to it, traveling through the wire to the ground. When they do this, they will power the horseshoe magnet for a split second, creating an electromagnet with the exact same field as the permanent magnet of the roller, repelling it. And this is how it self-runs. Now, you can create magnetic waveforms like an axial magnetic field. That's the goal. That only accelerates the motion of the rollers. It acts as an accelerator. But I don't think you need to do that. As long as you have an axial magnetic field, you should be fine. So that's what I'm trying to say. This static charge that builds up on the roller is extremely important, because if no static charge will build up, it won't jump to the coil wire and create an electromagnetic field repelling this roller to keep itself running. That's my point. Now, this is how it works. And also the magnetic field will intensify the faster and faster this roller goes. Also, the roller has